Okay, guys, let's do another question. The questions of the day. The question of the day is a distance. This question is a pretty classical question. The question is transform one string and another string with minimal number of operations. And the operations is three types of operations. We can insert element, delete element, and replace one element with another element. For example, to transform the horse into horse, we can replace the first 8 with or, blau, and remove the or, this or, remove the e, and remain only or, o, and s. Okay, how to solve the question? The question is a classical DP question. In 1DP, we must define states. Each state have will store a optimal solution for one subproblem. In this problem, we can solve using states like I, oops, I, j. In one state, ij, we will store the optimal solution of for transform this substring 0 to I in the first one into the substring 0 to j in the second one. For example, if I have a substring this state 2 uh, 1 to 1 in this sample, we need to store in this state the optimal solution to transform or into or into or, like this into this. Okay, the optimal solution in this case is 2. We need or delete 1 and replace another. I can delete 1 and replace another. Okay, to solve the question, we have two possibilities. The first possibility is using a backtrack solution. Use recursive with recursion solution, and another option is make the p table and solve the question interactive, which loops. Let's do the second options. I think that is more simple to understand. Let's do one big table. Empty string here 8 O or S here. Oops. Let's try make a good line. Empty string. After that, one or. After that, O. After that, S. Okay. Fine. Fine. The first thing is fill the first row and the first line in the solution. in the first line is the number of steps we need to use, number of operations to transform the empty string into one string, like empty string or 8, 80, 80 or, and something like. In this case, to empty is 0, empty to 1 is insert or delete, insert into empty or delete into not empty. We have 1, 2, 3, 4, 5. In this first row is the same. 1, 2, 3. Okay, and to fill the next options, what we can do, three operations, insert, delete, replace. Okay, in this state, if I delete the 8, my answer is to transform the OR into empty string. Then we have this option. If I delete 8, my final answer is 1, delete 8, plus number of steps we must do to transform OR to empty. If I delete OR, my final answer of this state is 1 plus the empty string to 80. 8. Okay, 8. If I delete, is simple. Delete is I minus 1 j, or I j minus 1 if I replace, if I try replace element, if I replace the OR with 8 or 8 with OR, this letter will be matched. Then my final answer is 1 replace plus empty string to empty string. If I replace, my answer will be calculated use the state I minus 1, j minus 1. Okay, if I try insert one element, insert one element into one string is the same of delete one element in another string. For example, if I try, let's check, 8 or transform into or, adding 1 8 here is the same of delete the 8 here. Okay, then we will ignore the insert in this case. Okay, then my another option is if the letter match, like OR to OR. If the letter match is the same of replace, but without count one operation, like if match, we can get the answer in this option. Nice, because if match, like OR to OR, in this case here, we need transform the empty string, the remain, into the remain of the another string. Let's complete like this. Or to war is 1 more replace is 1. Here 1 more replace, we can oops 2. And here if or match with or, we get this option and repeat here and make the same. Don't mat 3, don't mat 4. Let's check here. If checking this solution of the state, we can think to make the steps is make the opposite. To reach the state, delete A, delete S, match ORs, delete O, delete 8. Nice. And my final solution is the last state. Let's check the code. First, get the size of the first and the second. Create the matrix. After create the matrix, we fill the first line and the first row. Oops, the first row, row 0 and the line 0, and make. For each state, first try delete S2 in the word 2, delete in the SC1, or replace these three options here, here, here. All three options we need to plus 1, and if the letter match, we can do the match operation. Match operations get the diagonal in matrix without plus 1. If I submit the question, the solution, if I submit, okay, we do accept solution. Okay, guys, let's go. If you notice some English errors, please comment below. I make an English learning, and if you have some tips for me to explain more clearly, it's nice. Have a nice day. Good. Bye bye.